and to present our paper. The title Smartphone Application as an Air Quality Monitoring using Raspberry Pi for Reduced Air Population. Overview. Introduction. IoT with the ESP8260. The purpose system. Design and analyze, implementation and conclusion. Air pollution. The air pollution is mixture of colorless and odorless gas that fill the space above the earth for birds with the breath. But besides oxygen, they are of substance is the air sucks carbon monoxide, carbon dioxide, formaldehyde. Generally limit on the substance level can still be neutral, but it can interfere with health in its excited normal life. Good or bad air quality is influenced by daily human activity. The polluted air in the environment and in the room can also be contaminated by harmful chemicals and other materials. Air population can cause various disorders such as asthma, wheezing, and even coronary heart disease. Pollution can be done outdoor or indoor. However, people spend around 89% of their activity indoors such as work, home, and school and etc. IoT with the ESP8260 connect to the three sensors, and the ESP connect to server monitoring with communicate by wireless. The MQT7 can be detect carbon monoxide. We can so connected the port we mouse to the MQT7. This is simple to use carbon monoxide sensor, suitable for sensing carbon monoxide concentration in the earth. The MQ7 can be detect carbon monoxide gas concentration anywhere for 10 ppm. Thanks for PM. The sensor has high sensitivity and fast response time. The sensor output is analog resistor. And analog data from the MP7 sensor is processed into the digital signal on the RPI server. And GSS A1 can detect carbon dioxide. The GSS A1 air quality is digital gas sensor solution that detect for wide range of total volatile organic compound and include equivalent level of the carbon dioxide. The MQCAT 90 can detect carbon dioxide. The MQCAT is 90. Air quality is digital gas sensor solution that detect a wide range equivalent level of carbon dioxide and pollutant and or sensory irritant and can come from a variety of such and building material. The purpose system. This work measure the carbon monoxide level using the MP7 sensor and measure the air carbon dioxide level with the GSS A1 sensor and MRJ90. All those sensor is connected to the Node MCU ESP8260 and we call it a Node Setsu MCU module. Design and analysis. The design for our sensor, you can propose 3 node MC. Almost the node MCU connected to 3 sensors. MKZ 19 sensor, MK7 sensor, CSS 8.1 sensor connect to the WeMOS. So we have not MC1, not MC2, not MC3. And all the not MCU connect to server RPI. You can include the communicate by MQTT broker. So you can below in the table for host IP for not MC1 is 192.168.40.241. And not MCU2 hosts have IP address is 192.168.40.242, and not MCU3 hosts have IP address 192.168.40.243, and the server RPI MQTT broker have IP address 192.168.40.246, and the connect is by WeMOS. We can show in below this one. And then after we can connect it, the WeMOS to the all sensor, you can tap control input. You can setting the control for protocol HTTP and locate control for node MC1 and node MC2 and node MC3. And you can sort the controller port and the others. If you can control input 4, if you can control input 4, not MC1, we can set the IP address. We can set the IP address in locate controller. And then, in touch setting, you can set the name sensor and set port GPO using sensor, and to set control for IDX. And then you can control input for not MCU2 and not MCU3 for the other's IP address host. You can choose the same process. And we saw the implementation. The not MCU Node 1, the not MCU Node 2, and not MCU 3, you can choose in location area 1 an area 2 and area 3. And then all the node MCU is communicated by access point connected to the server. The access point can respond, communicate to the RPI by mosquito broker, and then the server have IP address. We said that the local MQTT broker is IP address host, empty broker, and access point to communicate the RPI server monitoring. You can choose by publish and subscribe using the library ESP8266 to access the GPU. And then we can choose to install all the RPI Mosquito Broker, Python, web server, and TT client. We can access the data and monitoring the data of the temperature activity for monoxide and carbon dioxide. And then after we can choose to install all Python web server by MQTT client. You can access by smartphone using the internet. Implementation. We can test by smartphone. By smartphone, we can choose the carbon dioxide and carbon monoxide. You can display the graph of carbon dioxide and then monodioxide. You can set when we choose the location area. And web server, you can display and monitoring the data of all sensor temperature by the web server. You can show web server access the data of the CCS 8.1. And then in the server, we can display the graph of the carbon monoxide and the others. Conclusion. Current technology, indoor air quality monitoring can also be integrated with the internet. The concept of the internet can be implemented on indoor air quality monitoring system. This work measure the carbon monoxide level using the MQ7 sensor and measure the level of the carbon dioxide in the air with the GSS 8.1 sensor and MQZ90. And all the sensors are connected to the Node MCU ESP8266 and we call the Node MCU module. Tests are carried out in the room in the house, then the Node MCU module are used so that their module will send the data alternate. User can view notification content and carbon monoxide and carbon dioxide condition in X from using the mobile application. Mobile application view result from the detection air quality anywhere because this design integrate with IoT device. Thank you.